Thanks for joining us on the Cultured Meat and Future Food Show. We have a very special episode today with Dr. Nina Buffi and Dr. Jan Saam from Ospin.de. Nina Buffi obtained her degree of microengineering in 2009 at the Swiss Institute of Technology, Lausanne. After an internship at the University of British Columbia, where she developed a microfluidic chip for impedance cell spectroscopy, she joined the Microsystems Laboratory at EPFL, where she obtained her PhD with a thesis titled Design and Construction of a Portable Whole Cell Living Bacterial Biosensor for the Detection of Arsenic in Water. In 2014, she moved to Berlin and later joined Ospin, a company aiming to establish an open bioprocessing platform as the operating system of modern biotechnology. Since January of 2018, she has been Ospin's CTO. Jan studied biophysics, and after simulating the complex dynamics of biomolecules on supercomputers, he worked as a product designer in the software industry. Later, he became an innovation manager at a biomedical think tank in Berlin, where he got interested in tissue engineering. In 2014, he founded Ospin, originally with a focus on creating automated bioreactor systems for tissue engineering projects. Meanwhile, Ospin's technology has developed into a modular platform for bioprocess automation with many different applications. Of course, Jan is excited about cultured meat and the fascinating challenges in bioprocessing it poses. This episode is co-hosted with Anita Broellochs. We are here with actually a very special episode. We've never had four people on the show at once, so welcome. I will actually, because we have four people, let's go around and introduce ourselves. So go ahead.
Okay, hi, I'm Nina. So my background, so I studied engineering, and then during my PhD, I got in contact with biology because I had to develop some devices for biology, and I realized how interesting is this mixture between engineering and biology. How interesting is like to provide engineering solution to biology, and so that's why at Ospin I found the perfect place to develop this and to develop this passion.
Hello, my name is Jan. I'm the founder of Ospin. I'm actually a biophysicist by training, and I did computer programming for a long time, like scientific programming. I was always interested in making machines that help biologists achieve their results quickly or more quickly. And at some point in my life, I came to the point where I had the chance to found a company, and we are creating bioreactor systems now.
Hi, my name is Anita, and I've actually been involved with Cultured Meat and Future Food podcast in the background a lot. I have been creating a lot of the questions, but I've never actually been on it, so this is really exciting to be on for the first time. And I am also a co-organizer of the Cultured Meat Symposium together with Alex.
Great, so let's go ahead and get started. First off, your team is based in Berlin. So tell us a little bit about the company and what you guys offer.
Okay, so we are a team of 11 people now. So what we develop is a bioprocessing platform. So it means that there are people that want to perform a bioprocess like you have cells in a state A and you want to have cells in a state B. This A to B can be cells expansion, cell differentiation, or many other things. And what we offer is a platform to achieve that. It means that we offer what we call bioprocessing modules. A bioprocessing module can be a pump, a pH sensor, a PO2 sensor, a glucose measurement. And our customer, the biologists, say, okay, to achieve my bioprocess, so I need this module and that module and the other module. And we then out of this module, we build the actual machine. So we offer customized solution for what they need, because our philosophy is that we don't want to sell a machine where the customer say, okay, now how I get what I want with this machine is more like, I want to reach something and I need the technology that does it for me. So we really offer something customized. And we do basically everything by ourselves in the sense that we do the electronics, the software, the mechanics. So we have a mechanics team, a hardware team, a software team that develop this basically.
Very cool. And anything to add? You seem like
Well, that was a very nice summary of actually what we are doing. Well, maybe one thing we could add is one of the main features of the platform is also that it is open to a certain extent. So we really encourage our customers to develop their own business models based on our platform. That means we are opening up the APIs, we are really helping our customers to also develop their own models, so they do modules. They do not necessarily have to wait for us to develop something. If they have their own great idea, a certain technology, a certain sensor that they want to hook up, they can do that themselves. And we're in general open to other technologies. That means if you have a device in your lab that you want to use, that's pretty cool, and you want to hook the data up into the platform, you want to integrate that into your bioprocess run, then you can do that through the platform. So we really encourage a co-innovation culture, and we are really proud that we could get so far with that already.
So one question I would have for you is, if a company, a biotech company, is starting out their bioprocess, but they don't really have a bioprocess in place yet, would your tools be helpful to get that running, or should a company have their bioprocess really set out yet? So what kind of scales can people work with?
Well, this is an interesting question. As like, we really also help companies like with developing their bioprocess. So we really go with the modules with them, also with the actual bioprocess with them, because since we are in contact with so many customers, we can also have some expertise ourselves. We can help the customer figuring out what they actually need to do. Of course, there is some minimum requirement, in the sense if you don't even know if you at all what you want to do, well, there is a minimum step that you need to know, like, yeah, I want to probably use a pump and probably need a pH sensor or something. There is some minimum requirement. Other than that, we also offer some kind of consultant services where they can really help them out to figure out what they need. It's not that they have to come have already in mind what they need before coming to us. That's the...
Okay, yeah. Very cool. And then so when the bioprocess, usually we start out really small, and then as the company grows, usually you want to produce on a larger scale. Is that something that they can do with you as well, or is it more for research and development phase of companies?
So we started with research and development because it's also easier for us, of course, but our goal is also to grow with them. So we are really eager to have a customer that says, okay, now we figured out something and we want to produce at a larger scale, and we want to either scale up or scale out, and we can just sell more of the same machine, or even make machines that are bigger and they are like suitable for production. So which is our goal. So we don't want to stay in this research and development mode, basically.
Yeah. So one of the things that one really has to understand, if you start out with a research project or with a development project, then you typically need a lot of flexibility. You're starting with something, you have an idea, you run a test, you run 2 tests, and then you want to change your setup. You want to change your bioprocess. And with regular bioprocessing equipment that you find in the lab, you cannot really do that. It is, in most cases, programmable only in a limited fashion. If you really want to go deep into it, it is not hackable. And you can also not change the setup very much. And all that is possible with our platform. And that means the whole platform is designed to develop with your project. So you can change it along the way. You can make it bigger along the way. And we're, in that sense, also a little bit driven by the requirements of our customers. If they go to the next step, we go to the next step with them. We might be at least half a step ahead often already. So with our platform, you can rely on a technology that develops and grows with your project.
Great. And so earlier we had made a couple comparisons from the Ospin platform to things like the Android operating system or even a breadboard. Tell us a little bit about how modular it is from that standpoint, and also, there's a strong focus that you have that the platform is really good for clean meat R&D. Maybe tell us a little bit how clean meat R&D is such a nice fit for the platform.
Well, cultural meat companies usually like at this stage are trying to figure it out their bioprocess. So it means they're trying to figure out how to grow their cells and so on. And so they need something which is flexible. So they need something which they don't know yet at the end how their bioprocess is gonna look like. So they need this flexibility to be able, okay, I buy this machine, but I can modify this and that and so on. So because they still don't know what at the end is gonna be. And this is why it's interesting for us, and it is a good fit, basically. It's not that until now we really developed something specific to the cultural meat field, even though I think that we are going to do it in the future. But until now, the argument is this flexibility to say you can modify it on the way. We are there to like support you on whatever you need. It's not that you are buying a machine and you have to somehow make it work for what you are trying to do. That's the main thing, I suppose.
So coming back to this platform question, it is our mission to become like the operating system for biotechnology. And so that's why we have this comparison with the Android system or any computer operating system. It's like an operating system is something that enables you to have business models based on that. If you take Android, some of the apps are provided by Google, but most of them are provided by other people that basically either give them for free or they have a business model based on their app. And a bioprocessing platform should do a similar thing for bioprocesses.
It fits well what Jan was saying. So it's a platform. So it means that somebody else can build on this. So the main idea is what we were telling also before is like we want to have open APIs and allow other people to develop something based on that. Because let's assume someone has a great idea to develop, I don't know, some special measuring device, let's assume. And of course, this super special modular measurement device, it can be interesting in itself, but if it's not integrated in something else, if you don't have a machine around it, so if you start to think, I have to put it into an incubator, or I have to together use a pH sensor and so on, it starts to be complex. But if this module is integrated in a platform that provides all the rest, well, the person that develops these modules is interesting for this person because he can sell better his module because it's integrated in a platform. And for us, it's interesting because maybe other people buy the platform also because we have this module, we can also sell this module. So it's interesting or profitable for everybody. And in this sense, it's open, and in this sense, you can see this as an operating system.
Another example where the platform character comes to life is we're also enabling other lab device makers to use our platform technology to equip their technology with these modern web-based or cloud-based technologies. So there's one example that a manufacturer of certain bioreactor systems in Europe asked us to equip their bioreactors with the technology out of our platform. So we're basically ripping out their electronics, put our electronics in, hook it up to the Ospin cloud, and then they basically have an Ospin compatible device. But they can still market it as their own, but they can make use of the technology that we developed.
And so, other than cultured meat being a good example, maybe what are some other hot topics within biotech that might also be a good example for this type of, would you call it rapid R&D, or because I'm thinking about it from a software sense, right? Like you have different terminology for being able to achieve very quick types of tests. Is there any other industry other than cultured meat that this might be a good fit for?
Absolutely. Cultured meat actually only recently was added to our business focus. We are already for a few years active in the biomedical field. We have many customers that are trying to develop test systems for drug testing, for instance. They are all tissue engineering based, so they need perfusion systems in which they can grow and keep alive their organ models, for instance, artificial blood vessels or cardiac patches or even neurons. And they're trying to build things like a blood-brain barrier. And they do also need interesting and flexible and complicated bioreactor systems to make these intricate processes work. One nice example is actually that we once built a gym for cells. Maybe Nina wants to tell the story.
This
about
is
this
a cool
project.
project. So there's a research group. They basically are trying to grow hair patches, so hair muscle cells. And what was cool about that, so basically you need to simulate them, so electrically and mechanically. So that's why Jan was saying as gym for the cells, because you need to train your cells so they become stronger. And also you want to measure the force that they produce. So it was really fun because we had to develop a system to basically simulate mechanically these cells and to also read the force that they are producing, which of course is super, super tiny, small. So from an engineering point of view, it was not so trivial to amplify these super small signals and try to see something. And the day that on the screen we saw the force produced because the cells are beating, so we were jumping in the lab, everyone, because we were so happy that we could see that. So really, really many interesting projects out there. And the cool thing about providing technologies, if you are in the biotech, you are doing it's difficult to achieve this to work on these projects. It takes many, many years to develop something. If you are on the tech side, by providing the technology, you can see many different projects that are developing themselves. And this is really cool because you can, of course, you are not the one who is doing it, but you can see many different projects evolving and you are active in many different fields, and it's super exciting, I believe.
We're seeing that technology, any type of software, and just cloud technology in general is advancing a lot of different industries. How is that advancing biotech or even lab equipment in biotech? I mean, you guys, the work that you do is a great example of that, but how is it affecting other areas?
Well, that's quite an interesting question. I think biology has gone through a very, very, very interesting phase in the last 2 or 3 decades. When I studied biology, it was still transitioning from accounting science to a science where you would do more molecular stuff and really start to manipulate cells. And nowadays, with the advancements of stem cell technology, for instance, biology has become much more of an engineering science. So engineering biology is so fascinating, and it opens up so many interesting avenues that we could go, that I really believe that the golden age of biotech is still to come, and we're just at the beginning of that now. And that automatically turns biotechnology into a data-rich science, which in former times it was not very much. And data-rich science and cloud technology and automation, that goes very well together, of course. So I really think that this is the direction that this field will develop. We will see much more sophisticated lab devices, and I totally believe that we will see a lot more lab devices being designed in a way that they can work together with other lab devices. So sending the data back and forth, letting the stuff work together, and having something like a smart and integrated lab, that's definitely the direction to go, and I really hope that we will be an important part of that.
Well, what is interesting for us is there is still a huge gap in the sense that if you think that in your daily life you use smartphone, use tablets, everything is in the cloud and so on, and the biology is still not like that. There is a lot going in that direction, but at least when I was doing my PhD, we were still writing on a piece of paper everything we were doing, and we were not thinking about having IoT in the lab, and so it's going in that direction, but still we are not there, and this is of course cool for us because exactly what we want to do, but yeah.
So the Berlin tech scene has always been really the central tech scene for any type of startup activity in Europe. A lot of people give London or Amsterdam credit, but I think Berlin has clearly shown us that that's where a lot of the startups emerge from. And it's exciting to see that ProVeg and also their new incubator is also touching some items related to cultured meat, which is really cool. I guess I want to ask a fun question first. And everyone here is, or at least the 3 of you, are from Europe. With cultured meat coming into existence, what is the first product you would like to see replace existing food in either Europe or from Germany?
I think I have 2.
Okay, go ahead.
Okay. I think a currywurst would be really good to have only clean meat in, and also döner kebab.
Yes, then a clean meat döner, that sounds really cool. I think would be super successful.
Yeah.
Yes, actually that's a very good idea, because döner is essentially an unstructured product. So it could be one of the first products that would actually work.
I think that'd be exciting.
And I think if a clean donor place opened up in Berlin, it would be a pretty popular spot. We'd probably see lines longer than Mustafa's if you guys have ever been
I think
there.
that would totally work. That would totally work.
In terms of events in Berlin, anything that we might be on the lookout for?
Well, we actually want to become a bit more publicly active. I mean, we're actually a B2B company, so we do not need so much public awareness here. But we would like to strengthen the scene in Berlin. We are planning to actually help you host some events in Berlin. So hopefully maybe in August or sometime in summer, we can do a meetup together where we bring together people that are interested in the cultured meat field. We know a few people that we can probably reach out to that would be very interested in coming, and your network also might help. And I think that Berlin really deserves an informal, interesting meetup where we talk about the future of food.
And that sounds great. We should make it happen. We hosted an event in Berlin focused on cultured meat. It was just a happy hour networking event. And I think that there's a lot of opportunity to do more in Berlin. There's more and more integrations between different types of, I guess, or software for the lab that connect to lab equipment. And this might not be something that exists currently, but could we see in the future someone has a protocol and they essentially like send to PDF or send to print, they can send to Ospin for it to run like a certain test or experiment, for example?
I think that would be super cool. And I think it might still take a couple of years until that's possible, because I think right now it might be hard to do, but I think in the future, definitely, I think the future of lab work will definitely look like something like that. And I think there will be less and less scientists actually doing the work by hand in the lab, and I think we will see more automation in the future. What do you guys think?
I totally think that this is a good idea. I mean, we were already thinking along the lines to integrate our stuff with electronic lab books, for instance. One has to think about a certain interesting aspect here. If you have a protocol describing how a machine carries out a certain bioprocess, then you have a digitized recipe of doing something in biology. And that digitized recipe, you can transfer that. So you can send that to somebody else, and they can then run that also on an Ospin machine if the machine is technically compatible. So that means sharing a protocol becomes a lot easier, because everybody who has worked in a biology lab knows this experience of trying to reproduce somebody else's paper. It can take a year easily to just do the same as the other one did. And even if you have a personal contact with him and they tell you how to do it, it's still difficult. And if you do that in a machine, it is much, much easier to reproduce that. And this digital sharing of protocols is part of our business model, basically. I mean, we are not owning these protocols. This is what our customers own, but our customers can actually share that either for free or they can sell it even. Like they can develop a protocol how to create a certain piece of tissue or a certain type of cell, and then they could sell this to others who also need that type of tissue to do certain tests. And that even applies to the field of cultured meat. If you think about the diversification that has to happen in the cultured meat field, or that will happen in the cultured meat field, we will see companies that produce the cell lines. We will see companies that produce the media. We will see companies that actually turn the cells into the actual meat. And there will be bioreactor companies. And we believe that in this diversification, it can be quite interesting that the super expensive part of building millions and millions of these production machines, that could be shouldered by many people, and then you would need a system where you have a fully automated machine that anybody can basically buy, and then they would get the license how to make the meat, and that could be quite fascinating, because then I foresee like a former cattle farmer doesn't have a stable with the cows anymore, but he might have a stable full of these meat production units, and he will buy the license and the cells from the cultured meat company and then produces the meat or the cells, and he has already access to the local markets. So regional production is actually, from an ecological standpoint, a very interesting thing. So we are trying to support this along the line of our development. We do realize that this is a few years down the road, but I think it's good to think now about these business models behind it also.
Yeah, that makes me think of two different things. One is the work that Yuki is doing, Dr. Yuki Henyu in Japan is doing with Integriculture and the Shogen Meat Project, the idea that we could one day have a bread maker in our kitchen where we send in the recipes. And I like how you use the term recipe, because when I hear people talk about serum, they usually use the term cocktail. And so very fitting for a future food show. But that's very cool. And then the other thing it makes me think of is really what Mosa Meat is doing with the mechanical engineering side of things, and really creating a machine that literally replaces where the cow might be sitting or standing. And so that's pretty cool. Let's shift gears a little bit and talk about design. We see that typical lab equipment looks like PCs of the late 80s, early 90s era. And it doesn't look that great. And I don't think it looked that great back then either. I think it was just cool that things could operate on it. Tell us a little bit about the Ospin design, a little bit about not necessarily the manufacturing process, but the design process that leads to the manufacturing of the physical hardware.
Well, this is like the design of the device is already like it's Jan basically that is behind it. As someone like our engineer had an hard time because Jan is keeping saying this is ugly. We cannot sell something like this. This is ugly. You have to do it like look nice, and it's always like something. If you come from an engineering side, it's not so obvious because your main focus like to make something work, right? So your main focus like, okay, it has to work. And then, well, the design comes after. But we were always there, Jan pushing, say, yeah, it has to work, but it also has to be a nice experience for the users, it's not just only has to work. Of course, the main part is if it works, but in parallel, we have to work on making the device looks nice. So on a mechanical point of view, and also in the user interface to make the user experience like as nice as possible, even though we are not so far yet in the sense that we don't have all the features and stuff, but still, also on this stage has to look nice.
Yeah, I just enjoy these kind of things, like designing something to be functional, but also beautiful. And when you think about if you build something and you have a lot of materials to choose from, yeah, you can choose the first best one that you find that does the job technically, but then you can search a little further and find a material that's beautiful or that gives you options for using different colors. And that's just what we did. And to be honest, I did not even put that much effort into it in the beginning. I just had a one-shot thing, and we showed it to customers, and they were just very happy with it. And we keep getting this comment, yeah, it really looks nice, we really love it. So I think that we had the right feeling for what they think is a very nice and modern looking piece of lab equipment. And so we will go on evaluating this this love of our customers for a nice object that is still functional.
Maybe perhaps even not color coded, but branded, depending on the company, or is that something you would never do?
Yeah, basically we have this, so the lid of the device is red because like our logo is red, so it's what we call the Ospin red.
Oh,
right?
I see, okay.
And we can imagine in the future to have different colors, just whatever we want to code with that,
right.
Or special edition, I don't know right now. This is a funny story. One of the last devices that we were delivering is that the company making this lid didn't have anymore this red material, so we had to choose another color, and we had an orange one. It was so ugly.
Oh no!
And it was terrible. And then we were lucky enough that a few days before the delivery we got this red material, so we could at the end sell this Ospin red and not this ugly orange.
Right. Okay. Very cool. So and it makes me think of. When I think of a biotech company, the first company that comes to mind is Genentech. That's a biotech company, right? And so I think of a Genentech blue or purplish color. And so maybe there's, is it blue?
I think it's green.
Oh, maybe it's green. I am, maybe I shouldn't say this on air as being a designer in my day job, but I am colorblind.
Yeah.
So maybe that's why I've seen Genentech as blue this whole time. I'll probably have to cut this part out. No.
I don't know, maybe it's blue.
Maybe it is blue. In any case, I could totally see the Genentech blue or the, I don't know, Mosa meat orange and blue or whatever it is. And so that's very cool. What is the best way to learn more about your products and to reach out?
Well, basically, drop us a note. You can contact us through our website. It's www.ospin.de. Ospin is spelled O-S-P-I-N. You can probably also read that on your website. So drop us a note there. We're free to share slides with you. We can talk to you. We are really happy to discuss what are your interests and your issues that you're trying to solve. So just get in touch.
Awesome. Well, thank you very much.
Thank you. This was
Thank you.
great.
Thank you. That was really a nice opportunity.